You're listening to The Ground Down, a podcast where we sit down with industry leaders and experts to discuss issues that affect the civil engineering industry. This podcast is brought to you by Ehra Engineering. Welcome. We hope that you enjoy the show.
Our first esteemed guest, Munroe Kelsay. He's a senior survey project manager and registered professional land surveyor at Ehra. And welcome, Munroe. Can you please tell us a little bit about yourself and Ehra and what you guys are up to?
Sure, absolutely, Corey. Thanks for having us on. Ehra is a multidiscipline civil engineering surveying company. We were founded in 1936. We're the second oldest engineering company in Houston, Texas. We currently have a staff of about 150 engineers and surveyors. Within our surveying department, we have about 6 to 7 field crews that we run. We have one UAV LiDAR crew that we have. We have 4 registered professional land surveyors on staff, as well as about 10 supporting staff, SIT and CAD technicians working for us. HRA specializes in, mainly what we do is single family development, but we also have areas of where we have mud districts, municipal utility districts that we engineer, as well as on the public sector with roads and bridges, as well as landscaping design also. And typically our projects range anywhere from 1 acre up to maybe 1,000 acres for a multi-planned community that's going to take 10 years or so to build out. And that's it in a nutshell for BHRA.
Awesome. Thank you so much. And thank you for being here, Munroe.
Absolutely. Appreciate being here, Corey. Thank you.
I'll start by asking Munroe and talking about a little bit about which LiDAR system do you use and on which platforms?
Basically, we're using the one you see in the picture. We have the DJI 600 with the Rigel Mini Ranger and a Sony 42 megapixel camera is what we use on our LiDAR system.
Nice, the A7R2 there. Yeah, that's a good camera.
Yes, correct.
Mm-hmm. What did you do before you had a Phoenix LiDAR system, and what did surveys look like before you had LiDAR, and how does that, compare?
So being down in the tropical area of Houston, we have a lot of vegetation down here. And prior to LiDAR, what we would have to do is send a conventional survey crew out there. We would literally chop lines about every 100-foot stations through the woods. We'd be chopping line with the machete in order to get natural ground shots through the tracts of land that we were actually surveying. It's very time consuming, obviously, and it drives the cost of a topography survey for the client up because it's just very labor intensive. With LiDAR, you obviously can cut that cost significantly to your client and also offer in the end, a better surveying looking model of what the actual true ground is as opposed to a conventional survey crew.
Yeah, I'll skip ahead here because I believe this visual is kind of describing a little bit of what you're talking about, this forested, treed environment, and the difficulties in getting through.
Yeah,
it's really difficult to walk through.
That particular one was about 100 acres, totally solid with trees in it. It would have taken a significant amount of time in order to chop line through there. And like I said, run out 100-foot stations between there. And then you're basically assuming that in between your stationing that nothing's happening on the ground. The beauty of LiDAR is on the left-hand side, there you can see that little screenshot there. It's the level of detail you get with it is just unsurpassed. I mean, you literally can see the tire tracks for vehicles. Once we flew over with the LiDAR, you could actually pick those out on the site.
For anyone that doesn't know, that image on the left, that's a digital terrain model extracted from ground classified points or derived from ground classified points. Go ahead.
That is correct. Mm-hmm. Yep. And then the one on the right-hand side, you can see the drainage ditch kind of running along the southwestern edge of the property there, but then you see those little fingers in this little ditch that's kind of closer to it. It's actually up in the woods, and you didn't even see it. And there isn't any way really that you can get a survey crew to get that level of detail, to get those kind of fingers. You would be spending a significant amount of time out there trying to get that level of detail that you can get with the LiDAR, just, with one flight through it. It's really is amazing, and it really has changed the way that we go about our single-family development and commercial projects that we deal with.
And what kind of point densities are you getting from like a standard flight through this area on the ground? So like with all those trees, with your mini Ranger.
So I can tell you on that 100-acre site, without thinning it out with just the ground only classifications, we ended up with about 13 million points on their ground only. Mm-hmm. In the very beginning, that was kind of significant to deal with. Trying to deal with 13 million points was a pretty big overload, and we kind of figured out a way to work around and kind of reduce that down and still able to keep the level of detail up enough for us.
And you do that by using, if I remember correctly, you use the TerraSolid workflow, and you extract some model key points from all your ground classified points?
Yeah, that's correct. We'll run it through the ground classified points. So we'll actually keep that file, and we'll turn around and we will run it through the model key points. And then with the model key points, we'll use that then to create a digital terrain model that our engineers use then for drainage purpose design purposes, as well as, during the construction phase services through this development of this project. We will actually create different digital terrain models along different significant points that are happening within the construction of the project.
So it seems like the big takeaway here is that traditionally you were taking kind of a shot every 100 feet through this kind of stuff. Is that correct? The 100-foot stations?
Yeah, and that 100 acres that you're looking at, probably right there, if I had to turn around and kind of give an estimated guess on it, I mean, we would be at least 2 weeks surveying that conventionally.
In the field, too.
In the field, yep, absolutely. And that's running at 100-foot stations. That's chopping our line through there. Now with LiDAR, we can go out there, we can fly it in half a day and be done. Come back in, process it, and I can actually have a digital terrain model within a day of having flown it.
So what used to take 12 days plus processing is now more like 1 day acquisition, 1 day processing, essentially.
Oh yeah, absolutely. And that's just one example. That's 100 acres. And you start getting into larger acres, and your time frame actually starts expanding quite a bit, as how long it's going to take you in order for the field crew to get the topo information for you.
Yeah. Let's move on to data products you were speaking about, digital terrain models. What are the most valuable data products that you've derived from LiDAR? I know you mentioned digital terrain model, but I see another image here on the right. Do you want to explain that one a little bit?
Yeah, so the image on the right, part of what we use our LiDAR for is we will actually, when a contractor comes in, we will have the undergrounds usually come in. They'll put the underground utilities in first, and the paving contractor comes in. And then usually within the paving contractor's contract is they usually do a final lot grade on the lots. What we do then is we'll turn around and we'll fly that site with the LiDAR then, that we can turn around and create a digital terrain model then that we can compare with our proposed digital terrain models. And that way we can show the contractor areas of lots where they need to fill some more, take some other dirt off to get it to that final grade, the design final grade. So it's a quick, simple way to kind of create this little heat map to give to the contractor saying, okay, you're deficient on these lots, you need to add some more dirt over here on these lots. So it's a quick and simple way to get that done.
Yeah, that seems like a fantastic use case. Like how would you do that without LiDAR? That seems very difficult.
So in the past, what we typically do is we would actually literally go shoot grades on every single one of these lots with the conventional crew. Typically you're getting a shot at the front of the lot, maybe one in the middle of the lot, and at the very tail end of the lot, the back end of the lot. The nice thing with LiDAR is you have the whole site covered, so you can see areas maybe in the middle of the lot, on the side of the lot, maybe where they have, some problems with their dirt. Or with conventional crew, you may miss that, you may catch it just depending on where they take their shot at.
Right.
So we have gotten to where we're mainly using this on this particular way that we use this on all of our single-family development. It's a quick and simple way for us to check the final lot grade to make sure that the contractor has put exactly the dirt where it needs to be into what grade it's at.
Gotcha.
On the left-hand side over there is a project that we did where we were called in to come on for behind another survey crew that actually surveyed this project, and our client was questioning the accuracy of what they did. He was questioning the dirt quantity that they ended up with. So we actually flew the site with the LiDAR, and the difference is pretty significant. The other crew unfortunately had some errors, I think, in their survey, so we found those errors and were able to help the client out. The main takeaway on it was that within that creek that you kind of see running through that wooded area there on the western side of the property, once again, you see the creek, you see these little fingers that are feeding into it, and you just can't, there's just no way to get that level of detail with the standard survey crew. You would spend so much time trying to get that level of detail that you'd eat your budget up. And it's just amazing what you can get with this and the accuracy of what you're getting with it through the trees.
Yeah, what accuracy are you typically achieving with your Mini Ranger through the trees?
So typically, and since we're a survey company, where we go out with LiDAR, we take a cross-section on our projects, 2 cross-section lines is what we run across conventionally with the survey crew. So I use those. I have our ground control points that we put down, but I also use those as an independent check. Then when we're all done with our LiDAR, create our digital model, then I can turn around and look at it and see, okay, what's the comparison of what I'm getting with my LiDAR compared to what a conventional crew would get at the same exact spot on the earth. So it's kind of a QA/QC check that we use internally to make sure that everything that we send out, that we have the confidence that it's right. Typically what we find in heavily vegetated area, wooded areas like this, what I'll find is my vertical accuracy with LiDAR is probably within about 1500s, maybe a little higher, a little lower in some areas, but for the most part, it's about 1500s. Yeah, vertically. Which typically what we'll do with our clients, if it's a heavy vegetated area like that, we'll fly it ahead of time, and we can turn around and we can kind of do our initial designs for our drainage and for our design for our subdivision. And then what happens then is a contractor will come along and clear the site. So we'll come along then after they've cleared the site and refly it again with the drone so that we can turn around and get a much more accurate model then after strip the trees out, because you're going to lose dirt, you're going to lose, when you come out there with as many trees you have and clear it on out, you're going to lose dirt on that. So, you may drop down maybe 6 inches in elevation, just stripping the site down of all the trees. So we'll refly that again and can get a much more accurate dirt model then from it.
I see. Great. So yeah, can you, let's talk about your workflow and data management. And so I know our attendees are really excited to hear more about, taking that LiDAR and then using it for surveying and for engineering. Tell us a little bit about, what we're seeing in this image and your workflow.
Yeah, typically our workflow, of course, we'll do we'll see where the area is we want to fly. We'll do our pre-flight, and then we'll actually go on the site. We'll actually fly the site. Typically right now is our LiDAR crew are the ones that are collecting the ground control points, just strictly because we kind of know what we need and where to get them and where they're good and where's a better area to put our ground control points. But then we'll also have a conventional crew that will come in, like I said, and they'll run 2 independent cross-section lines across the project so that we can verify that with at the end of it. We'll take that information then, we'll post-process it running through TerraSolid. We'll turn around and get our final, ground-adjusted points. We'll turn around and take that, we'll run it through Recap. And then from Recap, we turn around then and take it into AutoCAD Civil 3D, where we'll turn around and create a digital terrain model then that our engineers can use then for their calculations.
Okay, and then you create that surface off of that point cloud, and then from that surface you can derive contours and that digital terrain model.
Right. Once you get into Civil 3D, then you can contour it, you can do whatever you want to do. At that point in time, then we have a digital terrain model, And the Civil 3D is what our engineers use for their design calculations, so that way we can start comparing apples to apples when we have our dirt calculations done on the surface model.
Right. And then you were mentioning most sites that you're surveying, you get it down to local coordinates, and you do a scale and shift. Tell us about that and how you do that.
So everything that we do with our engineering department, everything has a local coordinate system that we use. Kind of a side note, the reason we did that is because we didn't want anyone looking at the coordinates and getting confused with state plane coordinates. So all of our engineering projects are on a local coordinate system, basically with the shift and scale. Everything is done in state plane, but we turn around then and we'll scale it up to true surface elevations and distances, and then we'll move it down to the local coordinate system. All of that is done through TerraSolid. Once we do our final adjustments in TerraSolid, one of the last things that we do is we'll run it through a scale and shift in TerraSolid and then shift the whole point cloud information into a local coordinate system then that we run through the recap and run through the Civil 3D surface model.
Gotcha. And that's scale and shift, but that's not rotate, right?
No.
Curious. Okay.
No, that's just a simple scale and shift that we do in all of our projects. It doesn't matter if we do the same process even with our conventional crews. We'll go out with our GPS and we'll shoot stuff in with GPS. Then we'll turn around and process that in the office, and we'll also do the same thing with the scale and shift where we get everything scaled up to a true one-to-one distance, and then we'll move it down to a local coordinate system. So if it's LiDAR or conventional crew, we run through the same process.
Gotcha. And then when it comes to dealing with challenges regarding big data sets, you were mentioning you do that model key point extraction to intelligently filter ground points and like keep break line areas, that sort of thing. Is that the best way you found to manage these massive data sets?
It is, yeah, because originally we weren't doing that at all. And of course I was getting, it was causing computer crashes because there was so much information we couldn't really handle it. So we kind of came through a happy medium and running through different variables on the model key points to where no matter if it's just a flat surface or if it's, has a lot of vertical changes in it, we kind of came through a happy medium of the numbers where I can kind of keep everything, and I'm sure that the model that we're going to create is accurate enough for the dirt models. Mm-hmm. So obviously you'd like to keep everything, but it's just your computers become so bogged down with that information that what we do is we just run through the model key points. That way that we're guaranteeing that we're keeping those hard break lines, those top of ditches, the toes of the ditches. You want to absolutely have that information in there. So you don't want to start skipping and saying, okay, I want to give me every 3 points or every 5th point. You just don't know what you're missing between those points. And so if you run through the model key points, you're guaranteed you're going to keep those hard break lines for you.
Right. Sure. Thank you. When it comes to market served, I know that, besides surveying engineering, that's your bread and butter, but do you serve any other markets that benefit from LiDAR technology, or any markets in the future that you're looking to jump into?
Yeah, like you said, probably 95% of what we do is for what I call them my inside clients. Those are the civil engineers that we have working on single family development. The bulk of what we do is for them. We do have some other outside clients, though, that I do some large commercial sites for them where we use the LiDAR on. It could be 200 to 300 acre large commercial developments that they're doing that we fly the site for them. We've also done 2 golf courses, which you see on the screen here as a result of that. We were approached from a golf course company here in Houston. They wanted to redesign their golf course. So we went at it and we did it with LiDAR. We turned around and did the photos with it, collected the LiDAR then and gave it to then the golf architect in California that's using it then to turn around and redesign their golf course, regrade, rechange everything up. We've done that on 2 golf courses. And as far as the future, there's areas where we like to see, some more areas we're kind of looking into the future, possibly maybe dealing with the stormwater management particularly down in this area down here, that's a big concern with the stormwater.
Especially right now, right?
Well, yeah, it's kind of you kind of get used to it, I guess. But yeah, we just kind of came through a flooding event, a couple days ago. So not as bad as Harvey, but it was still impacted people's lives with the flooding and all.
Right. Well, I'm glad you can make today's webinar, and yeah, thank you for all that you've shared and all your expertise that you shared with us. Yeah, we really appreciate that.
Absolutely, Corey. We thank you for having us.
We hope that you have enjoyed today's episode. If you would like to hear more episodes of The Ground Down, please visit www.ehrainc.com for updates. Make sure to check out EHRA Engineering on LinkedIn, Facebook, and YouTube for all kinds of cool content.